Hello. Module 1 was a bit confusing with all of its language. There's a lot there, and I think now that you're done with that, you might go, oh my, look at everything I've done. 'Cause I believe they did get into some conversions, and you had to understand the new cosecant, secant, cotangent functions using your calculator, all those pictures of angles. So we're going to build on that. And hopefully, by being in Module 2 in Chapter 5, just doing some very simple things, verify, simplify, solve, and working with identities, some of the things in Module 1 will start to become clearer and clearer, like conversions from radians to degrees and degrees to radians. Now, I am going to put my calculator back into degree mode so you can go fluidly between the two. The first video I did radians, and I did the sine of pi over 3. Hopefully you now know that the sine of pi over 3 is the same as the sine of 60, and then that is radical 3 over 2. Radical 3 over 2 doesn't show up on your calculator with radicals, although you could always take a minute and check to see that these are the same decimal. That's kind of cool. So sine of 60 is radical 3 over 2. And then hopefully you saw that when you did cosecant, you do 1 divided by the sine of 60. And that is the same thing as reciprocating radical 3 over 2, or you would have 2 divided by radical 3. Those relationships are important to get solid in your head, because we're going to have more relationships being thrown at you, and it's very easy to confuse them. One of the most popular confusion pieces would be this one right here. There's a button on your calculator I'm going to show you. It's the inverse button. And at the end of Chapter 4, you did learn some sine and cosine inverses. Sine inverse sometimes is called arc sine. And arc sine, we use that word in my calc class, arc sine of x. Arc sine itself, if you did something, whatever x you plug in there, you'll get an angle. So the big idea here is that when you're doing an inverse, you're going to get the angle back. Let me show you on the calculator. So I did sine of an angle, and I got radical 3 over 2. If I do the sine inverse, so second sine, see the inverse, the little -1 button, and I type in that radical 3 over 2, it should give me 60 degrees. This is an angle. It should give me 60 degrees. That is not the same as 1 divided by sine. So when I did 1 divided by sine, people think that the sine with a little -1 flips this over. It does not. So remember, sine of 60 was radical 3 over 2. And when I flip it over, I get 2 over radical 3, which is this decimal. But these are completely different ideas. So call this button, they're right here, sine inverse, cosine inverse, tangent inverse. Call them your angle recovery buttons. So we're going to get angles out of this. It's how you get angles. And that's very important when we want to solve. When we want to solve an equation and we want an angle for an answer, I'm going to use sine inverse or cosine inverse or tangent inverse. Now, the rest of this module, if you like puzzles, you will like verifying, because verifying is telling you a really long, ugly thing on the left-hand side of an equal sign, and then it gives you the answer on the right. And so all of the things over here that are quite ugly, it really could be like as easy, I mean, maybe it's not as ugly. Maybe it says sine, divided by cosine, for example. And then you had times, maybe we have a cosine, that your cosine squared. You'll see some of that multiplied by. And then maybe you're going to multiply that by a cosecant, okay, which is 1 over sine. What it'll ask you to do is simplify the left-hand side so that you can actually get the answer, and it'll give you the answer. So that's kind of nice that you'll have, and the answer here is just going to be cosine. that you'll have a bunch of ugly looking things on the left, and you have to work out like the algebra of them so that things will cancel and that you'll be left with it. But it gives you, like I said, it gives you the answer. So really, when you see the words verify, okay, this is a new identity, something that they made up that will always hold true for any x that you plug in. So the left and the right hand sides will be the same for any x that is in the domain that you choose there. If you had the instructions to simplify, you would actually not have any of this. So you would be asked, there's no equal sign. So verify has an equal sign and it tells you the answer. But simplify is just me working this out and canceling and showing you how simple this could be. And so I'm simplifying, always simplifying one side to get the answer. When you enter into solve, that is where it's a sometimes. Okay, sometimes there's an x that makes this true. So a lot of times you'll see sine x is equal to 1, and that is not always true. Your job is to find x that makes this true. One thing you could do to both sides is the opposite of sine, which is composing sine inverse with sine. So I could do that to both sides, and that was what I would type in on my calculator. So if I typed in sine inverse, sine of a 1, I would end up getting the angle, which is 90 degrees. So solving this 90 degree is going to make that sentence true. This is not an identity, like not all x's make this identity true. So that's more of a solve situation. So telling the difference among these words here is going to be part of the battle that we have to fight in Chapter 5, Module 2. Verify, simplify, or solve. What do you have? Solving is a sometimes x. Verify and simplify hold true for all x's. Identities are always true for all x's in the domain there. And that's kind of nice. Let's take a look at Alex real fast. So let's see if I have. In Chapter 5, in the original introduction here, they call this analytical trigonometry, and they have all these different formulas. These formulas are actually identities, and they're going to derive those. There's some fundamental ones at the beginning here that I want you to memorize because they are super popular. The reciprocals, this is where I was getting that 1 over sine, that's cosecant. The quotient ones, and at least this first Pythagorean one. The other ones aren't used as much, but those are going to be dominant throughout the course. So sine squared plus cosine squared is equal to 1. Here's a simplify with no equal sign. Let's see if they have a verify. There's a verify with an equal sign. So they've given you the answer. You have to make the other side match the answer. It is kind of fun to play with the identities. There's a lot of substitution with that. Good luck.